All right, picking up where we left off, the last problem, we came to the conclusion that whether you're doing the lower sums or the upper sums, your result is going to be the same when n goes to infinity. So here is the lower sum formula. There's the upper sum formula. They're basically the same. The only difference is m sub I and big M sub I. They're not always equal, but that's the difference in the formula. They are equal when n goes to infinity. All right, so the definition of the area underneath the curve, if f is defined on the closed interval AB, then we're going to use this guy. That formula looks like lower sums or upper sums. The only difference is we're going to use this c sub I instead of lowercase m sub I or uppercase m sub I. Okay? So if I would pick, like if I was finding the area underneath the curve, if I was picking the rectangle on this side of the point, this would be lower sum. It's underneath the curve. So this would be little m sub I. If I would pick the rectangle on this side, see how that little sliver is above? That would be upper sum. So that would be big M sub I. Okay? C sub I is equal to M sub I, lowercase m sub I, or capital M sub I when n approaches infinity, which means doesn't matter if you use lower sum or upper sum. So look here. The area formula for the area underneath the curve, if we take the limit as n goes to infinity, then we're going to use the summation when I is beginning at 1 to n of f of c sub I delta x, which eventually we're going to learn is the integral notation. This is summation, right? This Greek letter here. This right here is just a big S for summation. So we'll talk about this more in lessons to come, how it is the same thing as that. But you know, I want to make sure that you know the definition of the area underneath the curve, which is that guy, which we're going to use for the rest of today. So let's look at example 4. We're going to find the area between f of x equals x over 2 plus 2 and the x-axis, and x equals 0 and x equals 2. So let's go ahead and draw our graph so we can see what we've got here. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Let's graph the line f of x, x over 2 plus 2. So we're going to begin at 2. We're going to go up 1 over 2. Up 1 over 2. Okay. And then we've got x equals 0 and x equals 2. So we have a line here and a line here. And then also the x-axis, which is down here. So basically we're finding the area right here. So we're going to use calculus to find the area underneath the curve, even though we really wouldn't need to use calculus to find the area underneath the curve. We could just use some simple geometry. But that's okay. The process here, this will greatly benefit you understanding integrals and integration. All right, so we got to find the area. We've sketched the diagram. Next, we got to find delta x. So again, if we did some rectangles here, and if we did lower sums, it would look like this. We'd have 1, 2, 3. We'd have 4 rectangles where this would be x sub 1, this would be x sub 2, this would be x sub 3, this would be x sub 4, this would be x sub 5. And the width of each of these rectangles would be delta x. Okay? The height of each of these rectangles would be f of c sub I. Okay? So to find delta x, we're going to take b minus a. So 2 minus 0 all over n. We're going to make n going to infinity, so I'm just going to leave it as n. So this would be 2 over n. Okay? And notice that c sub I is the same as lowercase m sub I, which is the same as uppercase m sub I, when n is going towards infinity, which is the case because we're going to use this guy. So now let's fill in. So c sub I is going to be I times delta x, which delta x would be 2 over n. So this would be 2 over ni. So now we're ready to use our area, definition of area, which is the limit as n goes to infinity of the summation when I begins at 1 to n of f of c sub I delta x. And then we are just going to fill in and solve this. So this will be f of c sub I is 2n times I. Delta x is 2 over n. Notice that f of x is this guy here. X over 2 plus 2. So now if I substitute 2 over n times I in for x, I'll be left with the limit as n goes to infinity of the summation when I is 1 to n of 2 2i over n divided by 2 plus 2 guess I don't need two sets of parentheses there, times what happened there. See if I can get this to come back. Sorry, that crashed. Enter, try to fix it. Okay, we left off at this. Now I need to figure out this guy. So let's look at 2i over n over 2 plus 2. So here I could multiply the numerator and the denominator by 1/2. So that would cancel out. This would cancel out. So this is going to equal I over n plus 2. So now the limit as n approaches infinity of the summation when I is 1 to n. This would be I over n plus 2, 2 over n. Then I would distribute the 2 over n through here. So this would become 2i over n squared plus 4n. Then I can write this as two separate summations. And I'm going to factor out 2 over n squared out of the first one. And the second one, I'm going to factor out 4 over n. Then limit as n goes to infinity. This would be 2 over n squared all over n times n plus 1 all over 2. That's the same thing as this guy. Plus 4 over n. And then the summation of a constant would be a constant times n, so that's going to be n. Then the 2's would cancel out, one of the n's would cancel out. So this would be 1 over n times n plus 1 all over 2 plus 4. And then let's see if I multiply this through. This would be 1/2 plus 1 over 2n plus 4. Messed up somewhere.